Welcome to this podcast dealing with the nomenclature of alkanes. This comes from section 3.2. So let's go ahead and look. This first slide, of course, this doesn't look exactly like organic chemistry, but what is this? I'll pause just a moment, look at it, and see what you think. Of course, it is a nightmare. Scriptures tell us in Romans 1:20 that God's attributes are so clearly arrayed before us in nature that we are without excuse if we consign him to any role other than complete primacy in our lives, because creation shouts that he is Lord. You may have heard the verse in Romans where Paul says, "For since the creation of the world, God's invisible qualities, his eternal power and divine nature have been clearly seen, being understood from what has been made, so that men are without excuse." Pretty tough statement, but very true, and that God gives us so much evidence in his creation of his existence. So let's jump into nomenclature of alkanes. This is a little bit of a review, but you'll notice on this slide, it just lists one carbon methane, two carbons in ethane. Propane, of course, has three carbons, butane, four, and they're all surrounded by hydrogens. This is the Kekulé structure. And of course, the condensed structure, and then the ball and stick model. As you can see, each of these white balls are the hydrogens, and the darker one is the carbons. Let's look a little closer at nomenclature and get a feel for what we need to do. First thing I need to mention on this slide is that there's an error. Actually, there's two errors. One is carbon 4. You notice there's 4 carbons in each one of these two compounds, butane, and isobutane. Should be C4H10. And then down here we have 5 carbon compound, C5H12. So you might want to make that correction on your handout. C4H10 and C5H12. These, of course, are butane. Notice the iso structure, the isostructural unit, where it branches at the very end of the chain, so to speak, and it's known as iso. Here it is again, isopentane. Each of these have the same number of carbons and hydrogens, but they're different molecules. They're called constitutional isomers. They have the same molecular formula, but the atoms are linked differently. They have different properties and so forth. Here's 2,2-dimethylpropane. Another arrangement. Notice there's 3 different ways we can arrange the 5-carbon alkane. With this 4-carbon alkane, you notice we have 2 possible ways we can arrange them. Here is another slide with actually 6 carbons and 14 hydrogens. This should be corrected. C6H14. We have the common name of the compound and the systematic name given. And isohexane. I think you probably guessed that that's isohexane. There's 6 carbons, so it's called hexane. And this one has a methyl group off of the longest chain of 5 carbons, so we call it pentane, 2-methylpentane, and the common name is isohexane. And it just turns out hexane is the common name and the systematic name for the straight chain hydrocarbon. Here's dimethylbutane, 2 methyl groups off of number 2 carbon if we numbered 1, 2, 3, 4. And here are 2 other compounds, alkanes, 3-methylpentane. Notice 1, 2, 3. So 3-methyl, methyl's on number 3 carbon, so we know where it is, 5-carbon chain. And then here we got 2 methyl groups, one on number 2 and then another one on number 3. So we go 1, 2, 3. So 2,3-dimethyl, di tells us right away that we have 2 methyl groups, and the longest chain is these 4-carbon chain right there. Here is C7H16 can be arranged in 9 ways. So you can see as we increase the number of carbons, we definitely can increase the number of different arrangements. In fact, 10 carbon alkane can be arranged into 75 different compounds. If you had 15 carbons linked, there's actually 4,347 possible compounds that can be made up in different arrangements of the atoms, having the same number of carbons, same number of hydrogens. And here is heptane, isoheptane, as we've seen that structure before, or called 2-methylhexane, where we name this methyl group as a substituent on the longest chain, which is 6-carbon hexane. And then you can look at each of these here, illustrating the various substituents off of the main chain. For example, this one, we've seen 1, 2, 3, 4, 5. So we name it as a pentane, and we have 2 methyl groups, both off of number 2. So we say 2,2-dimethylpentane. Okay, let's look at alkanes and some of the rules that we've already been applying, but we haven't really talked about them in detail. The first rule is to identify the longest continuous chain, sometimes known as the parent hydrocarbon. Up here, it's real clear that the longest continuous chain of carbons is this that is highlighted and numbered 1 through 8. This methyl group comes off of number 4, so we can name it 4-methyloctane. Octane telling us that there's 8 carbons. And also here is 4-ethyloctane, but notice the longest chain actually is this one right here that's highlighted. You can count other ways and see that there are less than 8, but here's an ethyl group, this 2-carbon substituent off of number 4, so we call it 4-ethyloctane. There are 3 different alkanes with an 8-carbon parent hydrocarbon illustrated here. All 3 of them obviously are different molecules. They have different names, but they all have the same number of carbons. Now, we number the chain in the direction that gives the substituent as low a number as possible. And of course, we've already been doing that. We're numbering from left to right here to get 2 instead of 4. 1, 2, 3, 4. So it's obvious this ethyl group is closer to this side, so we're going to number it 1, 2, 3 instead of 1, 2, 3, 4. And here's a propyl group on number 4 of an 8-carbon chain molecule that's an octane, so we call it 4-propyloctane. So the number of the chain in the direction that gives the substituent as low a number as possible. Just a comment on common versus systematic nomenclature. Common names never have numbers. For example, isohexane. A chemist that recognizes this as a common name knows that this is the structure. Most chemists, however, will use a systematic name where you would say 2-methylpentane, and you immediately know that a methyl group is often number 2 on a 5-carbon chain. So there it is. Only systematic names have numbers. We list the substituents in alphabetical order. The correct name is the one that contains the lowest of the possible numbers. So here is a methyl group and an ethyl group. Ethyl comes before methyl, so we're going to number it to get the lowest possible numbers. For example, 5-ethyl-3-methyl-octane is better than 4-ethyl-6-methyl-octane because 5 is less than 6, and also 3 is less than 4. So this is preferred. So we'll number it starting over here. 1, 2, 3, 4, 5, 6. Actually, it's this way. 1, 2, 3. So it's 3-methyl, 4, 5, 5-ethyl. Then this longest chain is octane. Notice ethyl comes before methyl, and we go and number it in the direction to get the lowest numbers. What if we have multiple substituents? Chain is numbered in the direction that puts the lowest number in the name. Substituents are listed again in alphabetical order. There are some prefixes that we ignore as far as alphabetizing. Di and tri are ignored when alphabetizing substituents, as well as tetra, sec, and tert. Tetra, T-E-T-R-A, sec, S-E-C, and tert, T-E-R-T, are also used as prefixes that we'll mention in a few minutes, and you've already probably seen. So here's 2,4-dimethylhexane. Notice the numbers are separated by commas, and a number and a word are separated by a hyphen, which is a standard type of writing, what manner of writing these names. But 2,2-dimethyl tells us there's two methyl groups. One is on number 2 carbon, 3, 4, and the other is on the 4th carbon, and a 6-carbon chain. And we can look at this one down here as well. Octane, 8-carbon chain with a methyl group and an ethyl group. Ethyl comes before methyl because of E before M. And we number it to get the lowest number we can. Of course, there's a 2 for the methyl, so we'll number it this way: 2, 3, 4, 5. So 5-ethyl 2-methyl octane. When both have the same lowest number, go for the next lowest number. So if we have a tie, then we can break, we can't change that number, but we can number it in a way to get the next number to be the lowest. 2,2,4-trimethylpentane is better than 2,4,4-trimethylpentane, obviously because 2 is less than 4. See these two methyl groups? 2,2 is better than 4,4. So we number it from left to right. 2,2,4, 1, 2, 3, 4, methyl. Actually, it's trimethyl because there's 3 methyl groups, pentane. And the same principle applies on the right. When both have the same number, when the same numbers are obtained in both directions, the first group listed gets the lowest number. Somewhat similar to what we just talked about. But here's bromo, chloro. Bromo, B comes before C. So we're going to put the lowest number on the first one, 2-bromo. It's always better to get the lowest number if we can in the very beginning of the name. So 2-bromo, and there's 3-chloro. Butane. Same principle applies over on the right. Here's branch substituents, additional examples. And if we look at this one, notice we can actually have a substituent that's branched, and we can name this methyl group as a substituent on this 2-carbon chain, which in itself, this entire group here is a substituent. So we put brackets around 1-methyl-ethyl. This is an ethyl group, this is a methyl group, the methyl's on number 1, so we call it 1-methyl-ethyl. The 1-methyl-ethyl itself is a substituent off of number 4, 1, 2, 3, 4, of this 7-carbon chain. So it becomes 4 brackets, 1-methyl-ethyl heptane. And you can see the same principle applied in these others that are shown. Here's a substituent that has a methyl group off of it. Actually, it has 2 methyl groups, this one here and this one here. So we call it 1,1-dimethyl-ethyl. It's off of these 2. That's a 2-carbon chain, that carbon and that one. And then all of this itself is off of number 5. 1, 2, 3, 4, 5, and we number it left to right to get the 3 onto the ethyl octane. So that's what happens in that case. Chains with the same length, when 2 or more chains have the same length, the parent hydrocarbon is the chain with the most substituents. So this one has 2 substituents, this one has 1, and notice the longest chain is 1 through 6, and we have 2 substituents, methyl group, ethyl group, so we name it 3-ethyl 2-methylhexane. Here we have 1 substituent where we could number it this way with the methyl group off of the ethyl group, but there's only 1. It's better to do it and name it with 2 substituents. It's more clear in the long run. Here's just a review, just because they're numbered. You can see the first rule, the second rule that we've mentioned, the third and a fourth rule summarized on these slides, and number 5 and number 6 we've talked about, and number 7 and number 8. Certain common nomenclatures are used in the IUPAC system, and of course that's what we've been using, and we call it the systematic system. So let's stop right there, and you can take a look and review these before we go to the next section.